Alright, so the question says, we can make a simple model of a human vocal tract as an open-closed tube extending from the opening of the mouth to the diaphragm. What is the length of this tube if its fundamental frequency equals the typical speech frequency of 250 Hz? And then it gives us extra information stating that the speed of sound in warm air is 350 meters per second. So I made a little diagram right here of the human head with an open-closed tube right here. And this is very similar to an open-closed tube we have in our notes at m equals 1 when the frequency is 250 Hz. And I'll explain why we chose m equals 1 in a few seconds, but as to what the question is asking, it's asking for what's the length of this tube. And how do we find the length? So far the only equation right now that I know of, at the top of my head, that helps us find the length is this equation right here, which is from our notes. And the reason why we put 1 under the 4L is because m equals 1. And the reason why we chose m equals 1 is because it's giving us a fundamental frequency. And a fundamental frequency is the frequency which is the lowest frequency of a periodic wavelength. Meaning it's just the first harmonic series, or just when m equals 1. So when you plug 1 on the bottom, you just get lambda equals 4L. So that's why I put 1 on the bottom, and we just end up with lambda equals 4L, and to find the length, we can manipulate the variables to get L equals lambda divided by 4. But we don't have lambda, but we can find lambda from this equation right here, which is velocity equals frequency times lambda. And we can manipulate these right here, and now we just need velocity and frequency. And that's what we have here and here, which is the frequency being 250 Hz, and the velocity being the speed of sound in warm air, which is 350 meters per second. So at this point, we're just plugging in numbers. So I have our equation right here. We have V equals 350 meters per second, and our F equals 250 Hz. So we just plugged V over F, and I get lambda equals 1.4 meters. So now that we have lambda, we can finally plug lambda into our equation, which is L equals 1.4 meters over 4, which leaves us with the length being 0.35 meters. And that's our answer.